Okay, this is another attempt at making a video. Let's see how this goes. I'm actually new to this stuff, but let's see. So, what we are doing actually is, I said actually like 3 times. Fuck. What we are doing is we're going to, build a GUI from scratch. GUI for our PID simulator. Okay. So the idea, the broad idea over here is to make a graphical user interface to, how do I say this, to receive data from a PID simulator that we made. Okay, I'll show you, that's more easier to explain. Show you, this is what we want to make. This is a GUI, but this stand that you see in the middle, that's what we are building actually. Technically it's already built, but yeah, we need to make the GUI to actually control it. And yeah, so I'll zoom in over here. So the things that we are going to need for this is so this is what we actually need, right? So we'll have like 4 layers over here. You have the hardware layer, the firmware layer, communication, and finally the GUI software. The hardware layer is basically all of my hardware components. That includes sensors, actuators. For my sensors, I'm using an MPU 9250. I guess it's a gyroscope kind of thing. It is a gyroscope. And actuators, we have 2 actuators. We have servo motors and BLDC motors. Servo motors, we have 6 servo motors. 2 of them will be for thrust vector control, and 4 of them will be for roll control. I'll show you in this over here. So at the bottom over here, you can see these rectangular blocks. These are not blocks, these are servo motors, and heavy duty ones, by the way. And this will control the thrust vector of our rocket. On the top over here, you'll see 4 fins over here. You can see 3 but yeah, you get the gist. There are 4 fins over here, and we want 4 servo motors to control that. So, and apart from that, we have 2 BLDC motors. So like I said, 4 servo motors here, like 4 here and 2 servos here. So like 6 servos and 2 BLDC motors. So why 2? One of them is clockwise, the other is anti-clockwise. We want to simulate a roll. Okay, pitch, roll, and yaw. So like pitch, roll, and yaw. Yeah, so this is a very layman understanding. This is the roll. Okay, this is a pitch and this is the yaw. So this is my roll, and I think this is my pitch and this is my yaw. Okay, this is my yaw, if I'm not mistaken. But yeah, so but in our rocket, we assume that this nose cone, what do you see? If you imagine a line laterally, okay, crossing from the nose cone to the bottom, that is my axis of roll. So if it moves like this, I'll call it roll. Like that is how I'm defining this thing. Okay, so that's generally how it's defined. But yeah, don't go too much deep into the nuances. But yeah, this is my like these 2 propellers will control the roll over here. One of them is clockwise, and the other one will spin counterclockwise. So if the clockwise motor spins at a higher RPM than the counterclockwise one, so then I'll have a roll in the clockwise direction, and similarly vice versa. So that is what we want to simulate fundamentally over here. These are the individual blocks, CAD design. But what we want to do is we want to design this thing. This is the basic layout that we want to design. A friend of mine, Aman Chaudhary, he made the basic design in Canva, and this is what it should look like. This is the concept. these levers that you can see over here, these are for manually actuating the servos. So let me explain this in a more proper fashion, you can say. So I made this earlier, but I'll explain it once again. So suppose this is my canvas, very very basic canvas, plain canvas. At the center I want to keep, what do you say, a live display of the rocket, and I want to see it moving live. ठीक है, यहाँ पे like even if that thing like वो तो रहेगा, वो रहेगा, like stand रहेगा, but I want to see it over here moving in real time. So like an animation kind of thing, but in real time. So for example, suppose I'll zoom in over here. So suppose these are my gimbals, right? So these are my gimbals, and suppose this is my roll motor. This is my clockwise motor. Yeah, so this is my clockwise motor, and this is going to control the clockwise BLDC motor. And this position is 10 RPM, for instance, and this is 50 RPM. So when I increase the throttle manually, then I want it to roll in the clockwise direction, right? So that is what I want to do fundamentally. I'm giving a very vague idea, but basically idea yahi hai. On the left side panel we'll have live telemetry data coming from the ESP32 that we're using. Like it looks like this. So this is what we want. You have voltage, you have current, you have the angles at which each servo is oriented, and you have the RPM, okay, how much percent the motor is operating at. So this will tell you what is your direction of roll. And then you have PID. So honestly, we pulled all of this off from ChatGPT. I don't know what I'm doing, but I'll have to figure this out. Firmware layer mein we have three things. We have sensor acquisition, command receiver, and telemetry center. So basically what we want to do is, if we have multiple sensors, we want to collaborate those sensors to get information from the data. We just don't want raw data, we want information from the data. So we'll have to figure out a way to do that. We have the MPU9250 driver, and I don't know what these two are, Madvic filter and Mahoney filter. I don't know what these are. I pulled all of this from ChatGPT, to be very frank. I'll have to read more on that. And then command receiver. So like I mentioned, wait, I'll show you. Forget that. Yeah, this thing. So yeah, this terminal down here is, I don't know if you can see it. Let me just change. Yeah, I think that's better. But yeah. So this terminal down here, that gives us room to send custom commands. So for example, if I want to actuate RA, okay, servo RA, to move to 120 degrees, so I can just send the command over here, RA space 120, whatever, and then it will manually do that for me. That is the basic idea. And yeah, so for example, if one of these don't work, then this will cover up for us. That is the idea. And yeah, apart from that, we want telemetry as well from that, from the ESP32. So things like pitch, roll, and yaw, and then angles that we saw, like I just showed you here on this panel over here. And then the GCS architecture. GCS stands for Ground Control Station architecture. So this is the, I don't want to say like hard, but yeah, this is the crux of GUI programming. Okay, multi-threaded programming. This is the crux. So when you have something like this, like a complex architecture, then you want to have multiple threads running so that it doesn't freeze your program. So we have 3 threads over here. Like this is a very basic overview. Like I said, I pulled this from ChatGPT. I have to do some more reading on this, but that is the idea over here. And then custom tkinter. Custom tkinter is basically tkinter but with dark UI support. And then communication protocol will either use PySerial. PySerial is for when you're using, USB. Like when you're using a USB cable to connect to the ESP32 and then get serial data from there. That is PySerial protocol. I will personally go with WebSockets because wireless is better. And the only drawback with WebSocket is the latency. But ESP mein we have over the air communication, so I'm hoping कि latency नहीं होगा. Let's see. And then for plotting we have matplotlib or pyqtgraph. And finally, this is the most exciting part. For this part over here that I mentioned, this white box over here where I want the live view, there are a few libraries that I can explore, that I want to explore. Okay, PyOpenGL. For those of you who don't know, OpenGL is a C library, but we can use it in Python. I'm not actually familiar with that, but I have to read about that. And then you have VTK and other stuff as well. But yeah, I'm not familiar with all that. पढ़ना पड़ेगा. For now, let's just make the basic GUI. The fuck is my code? Oh, come on, bro. So this is the repository. Okay, so first things first, I need to create a virtual environment. मैंने वैसे कर रखा है. I've already made the virtual environment before recording the video, because I made another video and then so whatever. So the thing is, when you're using stuff like matplotlib and custom tkinter, these things do not come pre-installed on Python, so you have to install them using pip. Pip is kind of package manager for Python, if I'm not mistaken, but yeah, so you have to install it using pip. But there is another problem. If your environment is externally managed, then you have to use a virtual environment so that it doesn't crash for other programs. So I already made the virtual environment. We just have to enter the virtual environment. So I'm in the environment right now, and just like that we're in the directory. This is the basic directory that we have right now, that I cloned from here. Okay, कुछ नहीं है इसमें, proposal है, but inside this folder also there's nothing. There's the LaTeX documentation that I wrote like 5 months ago maybe, and yeah. So we have to build everything from scratch, and I hate this part. Yeah, let's start. So yeah, like I said, we have to install a few libraries from pip. For that, we have a couple of things that we need to install. Like we'll use a couple of things. So let me see what we have, what all we need. So I asked ChatGPT for that, but never mind. Yeah, so the first thing that we need is obviously custom tkinter. and I don't know, sockets maybe, I don't know, pi serial and matplotlib maybe, I think maybe numpy as well, and below as well. Wait, let me actually just ask ChatGPT. Yeah, this is what we need. See, I'll heavily use ChatGPT, there's no shame in that, because if a developer बनना, you can't just mug up everything, you have to use the internet sometimes. So I will be using that and Google heavily, so I won't pretend I know everything. I'm also very lazy to type everything out on my own, so I think I'll just delete everything and then copy this. Yeah, fuck off. Yeah, this is what we have. Yeah, and it's going to install all these files. That might take some time because sci-fi is a big module. क्या बोल रहा था? Okay, install हो गया. Now main.py. So first things first, when you want to build a GUI, I think the best thing to do is first you have to obviously import custom tkinter as ctk, and then I don't know, yeah, app.main loop. I think यही syntax, I think so. Let me check the documentation. Yeah. Okay, no, it's custom. Okay, yeah, it's correct. I think and there you go. There it is. This is my basic GUI. Very, very blank over here. But this is like a canvas. Okay, we want to paint on the canvas. So for doing that, we'll have to paint on this empty canvas. So this is what we want to do, right? Now how do we do this? I don't want to do this right now, it's too complicated for me. But basic चीज़ें होना चाहिए. What do we want? Let's see, what do we want for a very basic GUI? I want to control the servo motors. I want to get telemetry data. So WebSockets, I think I should import. Let me see. Let me see. Import socket, and then import matplotlib as plt. और फिर क्या करना है? That's how you add a button. So initially, do we need buttons? No, we don't. Grid geometry manager. So grid. I've got grid.column configure. 0 weight 1. Column 0 spans the whole window because it has a weight of 1. So by the way, this is not an educational video, this is not an entertainment video, this is a very boring video. Okay, I'm documenting this for the sake of documenting, for future purposes. Using frames, 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 frames. Using classes. Extended frame class. Multiple instances. I'll program it later here. Kind of lazy right now. This is what development looks like in 2026. Vibe coding, ChatGPT, and honestly, I don't know, yaar. I can read the documentation, but it's gonna take a lot of time, and I don't have that much patience to do it right now. Maybe someday I'll do it, but not now. That's how you do prompt engineering. Okay. I want you to basic canvas. Include. We actually use this image as a reference. This is prompt engineering 101. Yeah, I know I'm a very bad developer at this point, but I don't care. Shameless. Hopefully someday in the future, 3 years down the line, I'll actually write my own code, but right now this is how it is. This is what it's going to be like. And besides, there's nothing wrong with this. If you have a broader idea of what you want to do, and if you can tell AI what you want to do, then I mean, for me personally, what's more important is figuring out the circuitry, and then making sure the project actually does what it's supposed to do. Okay, I shouldn't have to mug up code and then do everything myself. If there are facilities available, then why should I? I mean, I don't have to hire 10 people to do one small task. That's kind of the advantage. So like, yeah, you can do things. I mean, something that a team of 10 people can do, you can do it alone today. That's a very beautiful advantage of AI, but you don't want to be too dependent on that. So I will try to learn my own. I'll try to learn on my own in the future. I'm over explaining myself, I know, but yeah. So we have the code. Let's see how this works for us. That's not bad. I mean, that's honestly not bad. So this is the basic code. Send motor command 48 50. What the fuck? Okay, that's nice. Actually, that's very nice. That's nice. So we want to change this part of the code of the UI to we do not want this button over here. Like I want that I want to manually increase the throttle and not have to click a button every time. So as soon as I do this, it should start picking up values in real time, and then send that data to the ESP32, then actuate the BLDC motor. So I think we need to change that part of the code, but okay. So this is good. I'll show you what I'm talking about. Like this thing over here, right? This is what I wanted to do. So this thing over here, I don't want to click a button. As soon as I move the throttle from here to here, it should automatically increase the throttle. Like, I don't know if any of you have used Betaflight in your life, then you know what I'm talking about. वहाँ पे एक option आता है, you can actually manually increase the RPM of the motor. So that is the idea. I'm not copying them, but yeah, that's the idea. I'm taking inspiration. It's a different thing. So yeah, this is the plan actually. So you know, this is, suppose this is 10 rpm, and then I slowly increase the throttle from 10 to 20, 30, 40, and then 50. So it should, in real time, it should take the data and then actuate it on the thing. So this looks fantastic. See, this is what I'm talking about. See, if I had to program this myself, आपको समझ में आ रहा है कितना टाइम लगता? This is not plagiarism. I mean, idea is my own. It's my own idea, and I'm just using AI to make it faster. I don't know why I'm justifying this so much, but it feels kind of wrong to, you know, copy everything from ChatGPT. But yeah, I have bigger problems at hand, honestly. Like, you know, stability of my rocket. That's a very, very big issue. I'll actually show you what I'm talking about. So we conducted our first test like yesterday, and it was extremely pathetic. So we went to this place called Ajwa Lake over here. It's in Vadodara, and I'll show you, like this is a lake, okay, by the way. It's a very big lake. It's huge, okay. From here to here, I think the diameter is somewhere around 2 to 3 kilometers at least. And on this, you know, tiny strip of barren land, somewhere around here at this point, exactly over here. Yeah, over here. So exactly at this point, okay, on the map, this is where we conducted our test. And I'll show you the video. 1 second. I don't think the audio is being accepted, but yeah, let's see that once again. 2, 1, ignition. Yeah, so this thing that you see over here ना, ये देखा है, ये चीज़ 50 सेंटीमीटर का है, by the way, बॉडी ट्यूब, ठीक है, और ये इतना तेज़ी से उड़ा, I didn't expect कि it will go that fast and that high also. Okay, I used about, I guess, 224 grams of propellant. I don't know, let me check. Prop mass 274. So yeah, 274 grams. I know that's including the motor casing, but yeah, I think like 250 grams. 250 grams, and I don't know. This is like 50 meters aram se. I was expecting it'll not even cross a coconut tree, but this flew unexpectedly. And what actually happened is, if you look closely at this direction, this is actually, you know, slightly at a 45-degree angle from you know, facing straight. So yeah, so this is the place from where we launched, and we are facing, the camera is facing this direction. The rocket launched in that direction, and when you're near a lake, the wind usually flows towards the lake. So what happened is, it was flowing in this direction. So I mean, from the video, from what we can see in the video, this is a canal, by the way, and this is a cut side. Okay, यहाँ पे पत्थर रखा हुआ, there are stones in this place. It's kind of a like a drainage system, you can say, and this is the road. Okay, this is a slope, okay, vertical slant, and this is the canal. Like, this is elevated ground over here, and this is the lake. Okay, so from here, from this point, it went in this direction, and the altitude at which, from what I can infer, it crossed this place and it went here. So yeah, so that was kind of unexpected. I didn't think it'll go that far. There were many reasons why this failed, by the way. My hypothesis, personally, from what I can infer from this video, is that launch log was too small. Like, बहुत छोटा था, कम से कम 2 मीटर का होना चाहिए था launch log. In fact, you can see that this thing over here, this structure is 2 meters long, but from where the rocket is mounted, उसके ऊपर 2 मीटर नहीं है, उसके ऊपर मतलब अंदाज approximately 1 meter होगा. तो the exit velocity when it left the launch arc, I mean the velocity was not stable. ठीक है. Small rockets like this with a very high impulse motor, they need at least 2 meters to get a stable launch velocity. So by the time it reaches this tip, it should have reached a stable velocity. But that happens when you have a 2 meter launch lug. Okay, like it should be long enough. It should be at least 4 times the size of the rocket, at least. Okay, this is 50 centimeters, and you have 50 centimeters on top of that. So like, if you notice carefully, before even leaving the launch pad, it was already tilting in that direction. If you have seen videos of BrahMos, okay, this is exactly what happened. Okay, BrahMos takes off vertically and then 90-degree turn, and then boom. That's what happened over here. Like it's crazy. It's not a success, but yeah, you have to learn from that. And also, by the way, motor हमने खरीदा नहीं था. This is 100% custom made, and it did not have a nozzle. So because of that also, we had uneven combustion. So you can see यहाँ पे जा रहा है, it's wobbling kind of. So that's there. And then launch lug was too short, and wind direction. These are 3 big reasons why this failed. So yeah, I have to deal with this also. So that's a completely different zone. So I can't focus on writing my own code at the same time. So yeah, copying from ChatGPT is not exactly bad when you know what you're doing. But yeah, that is kind of like okay, coming back to the GUI. Okay, the right panel is good. Oh, this is also nice. Left panel, center panel, then right panel. Okay, we have to change this part of the code. Okay. Fine. This part of the code needs to be changed, right? Where is it? Let's see. Yeah, good back. And yeah, कहाँ थे हम लोग? Over here, yeah. So this part we need to change. We need to change all the way down to self.motor to slider. Okay. So this part needs to be changed. Delete. And copy. Okay. And then print source part. Yeah, I think that's it. Indentation matters. ये नहीं shift हुआ. Shift it. ठीक है. Okay. That's all right. Let's check. We were actually supposed to, add these. Wait, what the fuck? It's fine. Yeah, we were supposed to add 2 more commands over here. So, I mean, that should do it, I guess. Yeah. And then, yeah. That's nice, I guess. Yeah. Okay, let's see. No, it does not remove the button. It still has. Okay. This is not exactly connecting right now, but yeah, backend we haven't figured it out yet, but we will do that very shortly. Where is the backend? Wi-Fi. So it's not actually doing anything right now. It's just like when I click the button, it's transforming that into connected, and yeah, it's not actually scanning for Wi-Fi. You'll have to these are the things that we need right now. Okay, one thing I learned is that Perplexity codes better than ChatGPT sometimes. So I think I should use that as well. how do you connect it to the Wi-Fi? Okay, so usually what happens is होता क्या है कि होता यह है कि हमारे पास मान लो हमारे पास क्या है ESP32 है, राइट? हमारे पास है ESP32, ठीक है, ESP। तो ये जब एक सर्वर होस्ट करता है, ठीक है, या फिर whenever it connects to a Wi-Fi, so in this case suppose it connects to my mobile Wi-Fi, so this will create an IP address, so it will have an IP address. Now when my laptop connects to the same Wi-Fi, I can see this IP address, ठीक है, so I can see this IP address. I'll show you an example. Okay, ball the example for now, but yeah, the IP address exists over here, and what happens is I can actually connect to this IP address, and then fundamentally I'll be connected to the ESP. So over the air connection directly we can achieve by connecting to this IP address. So if I know this IP address, I can communicate with this ESP from my laptop. I don't need any intermediate wires, तो कोई तार वार का ज़रूरत नहीं है. तो this is how it works. तो ऐसा कुछ IP address होगा 192.168, ये blah 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 blah. So how do I achieve that over here? How do I do that? I'll have to start Wi-Fi over here. So, yeah. Let me clarify how I'll do that. 1 second. Okay, so how do I connect to the ESP32? Don't write the code yet. Just tell me the connection flow. So that's what I said. It connects to the Wi-Fi, it starts a server, and then it listens on the port. And the port can be anything. Okay, like there are a few ports here which are resolved, but that's below I think 2000 or 1000, I guess. But yeah, ports like 8080 or 5000, that's practically unused. So यहाँ पे इन लोगों ने 5000 use किया. And yeah, we can do this, we can do this, we can do this, we can do this. So let's actually write the code. Assume I know the IP of the ESP32. I want the GUI to connect to a certain Wi-Fi. PSSID is it's my mobile Wi-Fi, you can't reach it. Let me try. Okay, password is whatever. So and then I want it to start a search for the ESP32. If it fails to connect after, suppose, I don't know what, 10 pings, let's say, then I want to stop searching for ESP32 and continue. What do you say? And just exist on the app. So I think you need getting the structure. Looks like this. Very good. Hmm. Thread 2. I seriously need to learn how to code. Hmm. Okay. We have the ESP. Yeah, we have the ESP. Let us see. Let us see. So, by the way, this is the ESP32 connected to a breadboard. Yeah, hope I'm audible. This is the ESP32. Yeah, and I'm going to try and establish a Wi-Fi connection to it. I think I have to go and have dinner क्योंकि 9 बज गए. I mean it's 9 p.m. right now and mess will close in 20 minutes. I have to go. I'll just do this part. Yeah. Okay. Let's see if it works. Okay, that's actually not bad, but how do you connect? I have to turn on my phone hotspot. Mobile hotspot. Turn it on. Okay, I have to connect to this Wi-Fi. Let me see. Let's see. Okay. I think it works. Yeah, it's working. So laptop is connected. I don't know if you can see this, but let me show you the screen. Okay, can you see this? I don't know if you can see this, but let me try to move it down for you. Yeah, can you see the screen? Yeah, it's connected to my mobile hotspot, but yeah, the ESP is not connected to this Wi-Fi right now, so it cannot, like the thing is failing. So yeah, scrolling चल रहा है. Oh, ठीक है, it works. I think so. It works, but yeah, it's fine. I'll work on this afterwards. Let's see.